Hello everybody, how's everybody doing? Hope you're doing fine. Checking some things here to make sure everything's okay. Okay, we have a good day today. So if you stay tuned, you might learn something. First I want to mention again, I always like to mention this, we have a conference in Lusaka, Zambia. So if you're interested in meeting some great people and having a great adventure, well, it's about a month away, a little over a month away. So get your tickets, get ready, bring your bags. You're going to meet some great people. Okay? All I can say is don't miss it. We've had some great conferences in the past, always with great people. The other thing I want to mention is, once again, we uploaded a book. It's a free book. You can download it. You can get up to speed on the rope model of light and gravity. And yeah, it's a 160-page book. If you have a second language, like some people have already volunteered, please contact us at tokakaka@hotmail.com and let us know if you want to translate it. I'm translating it into Spanish these days, and it's probably going to be out soon. Okay, I'm going to start a Spanish channel. Stimulated, really. I've got the channel already. So we're going to have these transmissions in Spanish as well. And so what I want to cover today is begin by covering some of the comments that were made. Always like to do that, get those out of the way, because it shows what people are not understanding. And a lot of people are just hit and run visitors. They come, they hear a little bit, see a little bit superficially, and they ask questions, but they haven't taken the trouble of sticking around and finding out what the site is about. And so they just have, one of those impromptu questions in their minds, and they just ask it, So, but anyways, I do want to address those issues anyways, because other people have the same questions in their minds. They probably don't ask them, but they don't understand really what one is saying, okay? So here goes the first one, okay? We have this fellow, he says, I'll start with the word object. Okay, good. Bill states that an object is something which has shape. Yes, that's what we propose. That's the definition of the word object for the purposes of physics. He uses this word specifically several times because it means you can't question him about it. No, it's not that you can't question me about it. It's that first we need to define the word object for the purposes of physics. And all I'm saying is this is my definition. If you got a problem with it, then you got to challenge the definition. And the best way that you can do it is by proposing an alternative definition. And that's where everyone who comes and criticizes lacks. No one comes and says, look, this is what I propose instead of your definition. Nobody says that, okay? So let's first justify that we absolutely need to define this word for the purposes of physics, okay? That's got to be justified, okay? You can't just say, well, you need to define the word, I don't know, table. Well, do we for the purposes of physics? Well, maybe not, but the word object is absolutely critical if we're going to talk about mechanisms and if we're going to try to explain how Mother Nature runs her shop, okay? So, yeah, the word object needs to be justified. Here it is, okay? Here's the universe, okay? With nothing in it, okay? Do you see any motion? Do you see any activity? Do you see any phenomenon happening there? Well, I don't think so. There's nothing there, okay? That's why you don't see anything in there. No, a universe has to have matter, okay? Has to have stars, gases, something moving, okay? And all motion is mediated by objects. Okay, you have to have an object to conceptualize motion. In fact, you have to define the word object before you define the word motion in physics. Okay, so let me get this other one up here. If I can find it, here it is. So we end up with the golden principle. This is what this takes us to. Physics requires an object. You can't do physics without an object. What would there be to study if you had no objects in the universe? Not a single atom. What would be moving? Well, what are you staring at? What are you imagining? What are you visualizing? There's nothing there. So you need objects. The universe, so-called universe, that's a word we use, right, to refer to that stuff out there in the universe, black stuff plus all these little stars that we can see at night. All those are stars, planets, gases, atoms. That's what they are. You take all that away, there's nothing there. There's nothing happening. There's no gravity, no nothing, because there is nothing there. Okay, so you need an object to do physics. That's a non-negotiable premise. You start there. I call it the golden principle. Okay, you need an object. Therefore, you need to define the word object for the purposes of physics, which is what this fellow, as well as so many others, never do. They never tell you what an object is. They just tell you what it ain't. And they don't like the shape criterion because it destroys their religion. That's why I say the scientific definition of the word object destroys all religions. Once you learn exactly what that means you have graduated from rational physics. You have to understand what that last corollary means. Okay? Yes, once you define the word object, let me give you an example. God disappears because God has to choose. God cannot be an object and a concept. God is either a concept or an object. God either has shape or God doesn't have shape. Which is it? Which is your God? And if it doesn't have shape, if it's a concept, then you're praying to a concept. And if it's an object, if you want them to exist, in addition, it has to have location. So yeah, you need to define the word object for the purposes of physics. When this fellow defines the word object, we'll address some of his other issues. The other issues are irrelevant if he doesn't know what an object is. Okay, so that's the first word he needs to define. Okay, and here's a second comment, I think from the same fellow. It says, unlike the rope Bill carries around with him at conferences, this rope, and I guess he's referring to this rope, my magic rope, Wonder Woman lasso. That's my rope, okay? Unlike this rope, right, the electromagnetic rope that this simulates, that this represents, is intangible. Yeah, okay. Definition of the adjective intangible is unable to be touched. Yeah, okay, good. And or not having a physical presence. Wrong. That's the mathematical physics religion notion of intangible. Intangible does not mean it's not physical. Okay? And again, if the only criterion is shape, then there is no provision for touch or for see. Okay, let's understand that. And again, it's up to him to define object otherwise. He's got to go back to the definition of object. That's why it serves no purpose to answer any other questions that he might have unless he can tell us what an object is in his religion. Okay, that's a sine qua non. He's got to start there. He's got to tell us what an object is so we can follow what he's talking about. We don't know right now what he's talking about. And see, he's talking about tangibility. He says, so first issue, how can a physical entity like an electromagnetic rope be intangible? It's like saying an object is a concept. Please explain. Yeah, very easy to explain. Very easy to explain. Here it is. First, not all objects are touchable. But he is using the see-touch criterion by default. In other words, he hasn't defined the word object. He doesn't pay attention to the fact that I defined it as shape, and he's already moving on, and he says, oh, we can't see or touch. Well, where did this come from? Where did this touch and see criteria come from? Why did he come up with that? Where does he have a definition of the word object involving the word see and touch? Okay? So if you have that criterion there, and we put it next to the rope, which is here, okay? Object is that which has shape, okay? Does the rope have shape? Yes, okay? It has the same shape as the rope that you buy at the hardware store, 2-strand twined rope. So, rope has shape. There it is. In fact, all ropes in the universe, even in the land of the Klingons, had better have shape, because the word shape, the word rope refers to that which has shape, always. Like the word table. Table is always a physical object, even the imaginary ones, okay? Because they have shape, not because you can touch them. And the electromagnetic rope does not have the same properties as the rope of our everyday experience. You can't use the senses, okay, specifically see and touch. So it's irrelevant for him to talk about intangibility when intangibility is not a criterion for an object, okay? And here's why we exclude it completely. You cannot use any of these criteria, okay, to define the word object for the purposes of science, for the purposes of physics. You cannot use see, touch, mass, volume, motion, made of, it's known as mereology, what the table is made of, not a scientific definition, too lengthy to cover here today. Or temporal parts, involving time. It can't be the subject of a sentence that's in ordinary speech. That's what a noun is for the purposes of ordinary speech. For the purposes of physics, a noun is that which has shape only. If it doesn't have shape, like the word orbit is not a noun for the purposes of physics. It's a verb. And so we need to understand all these things, okay? And the word infinity, which we're hopefully going to cover today, is not a noun. There's no such standalone physical object called infinity. So you cannot talk about infinity on its own. Like I'm going to talk about, in my physics dissertation, I'm going to talk about infinity. No such thing, okay? And the others, color, you cannot confuse it with the word exist. And certainly an object is not that which is 3D, because we have 2D objects as well, and we have to cover those in physics as well. We have to identify them. So if it's a 3D or a 2D object, all you're doing is putting an adjective in front of the word object. You're saying this one is 3D and that one's 2D, but you're still talking about an object. You're just talking about different. It's like saying this is a black object and that's a white object. You have the word is object that we need to define, so you can't use 3D or 2D as criteria. And so since he mentions touch, let's find out why we can't use the word touch as a criterion. That's the only one I'm going to address. Okay, here it is. Summary. Why touch is not a valid criterion for defining the word object for the purposes of physics. Touch is a verb. We must define objects before we define motion, because only objects can perform motions. You cannot have a concept like love perform motion. You cannot have a concept such as intelligence perform motion, in great measure because they're already concepts that are in motion. They are dynamic concepts to begin with. Okay, that's the main issue. But then we have touch requires two objects. You need to have two objects come together and touch. And so you need two objects when you're trying to define what an object is. So you're talking about not only a verb, but you're talking about getting two objects to do that verb. Okay, you need the asteroid to hit the moon before you can call either one of them an object. That's the problem. Okay, so it's a circular definition. You need two objects to define one. And again, touch means two objects, right? It's going to make contact. And the conclusion: the verb must touch invokes two objects and motion to define the word object. Okay, so it's a circular definition. And again, you have to define object before you use any kind of verb as part of the definition of the word object. So yeah, you can't use touch or see. See is also a verb, by the way, for those who don't know grammar. So you can't say, well, I can't see the rope. Well, yeah, it's irrelevant, because that's not the definition of the word object for the purposes of physics. So define object in the alternative if it's not shape. Okay, if you can't define it with that criterion. Okay, here's another comment along the same lines also, because all these people, the only thing they can think about is see and touch. That's all that comes to their mind, okay? And what is the thickness of the electromagnetic ropes? The thickness, like that's important? I don't know, it's very thin. We don't care about numbers in physics. That's that doesn't explain anything. It's very thin. Is that close enough? And it says, how can every atom be attached to every other atom without it becoming a bare garden of tangled confusion? Again, these people are thinking of touch. And the same question here. All he's got to do, all this fellow has to do is define the word object for the purposes of physics. And hopefully he doesn't define it in terms of touch. And that's it. That's the only thing that we need to address. That's why, you know, it's fruitless to talk to these people unless they understand the definition of the word object. And it takes 2 years, like I say, for a mathematician to understand what the word object means, because they never deal with objects. They deal with numbers and they think they're doing a representation of the real world, especially mechanisms. They're not. All they're doing is describing. They're not explaining the mechanism. In order to explain, you need to make a movie. What are you going to put in a movie? Hopefully you put objects and not numbers, okay? So, another comment, always along the same lines. Here's another fellow, and he says, ropes are observable objects. Observable. You got to observe, right? You got to use your eyes, right? Gravity itself is not observable. Okay, so you can't observe gravity, but ropes are observable. So we got an issue here, because if you can observe the rope, like if you go to the lab or you do an experiment in the field somewhere and you say, I observed gravity, I saw the rope or whatever, then for sure you have not seen gravity, because like he says, their gravity should not be observable. If you see gravity, I don't know what planet you're in, but hopefully you haven't taken too much, booze, okay? No, hopefully what we're trying to answer is the invisible stuff and untouchable stuff that Mother Nature uses. And so if you see or touch something out there and you say, I touched gravity, I saw the mediator of gravity or of magnetism, well then you haven't touched gravity or the mediator of magnetism, okay? All we can observe about it is its effects, yes. And invisible ropes, he says. Have you ever observed such a thing? Hopefully not. Hopefully, I mean, after 10 beers, I may, okay, I can make an effort and maybe see the ropes, but hopefully I should not be able to see the ropes when I analyze gravity. If I go to the whatever, if I let go of the pen, as I always do my little experiment here, you get a pen, you let it go, and it falls to the floor, okay? And if that's the case, I should not see what pulled or pushed on it. By the way, push, we got the same thing. I mean, these people never asked the question they should have asked, and that is, assuming you're going to simulate gravity with particles, have you seen the particles of gravity? Have you seen the gravitons pushing on the pen, for example? But they never asked that question. It's only when you introduce the ropes and say, look, we're going to do this with ropes. Instead of push, we're going to do it with pull. And they say, but I don't see, I can't touch the ropes. Well, you couldn't see or touch the particles that pushed either. Why didn't you ask the question then? Why didn't you ask the person in quantum mechanics or the person in general relativity, where are the particles? Why can't I see the particles that you're using to push? Okay? And see, they never ask that question. For some reason, that question only pops up when they're analyzing the rope. How come they don't get tangled? Well, how come you didn't ask that question about quantum mechanics? How come the gravitons can be many of them at the same place at the same time? How come one particle can be at two places at once? Nobody asked those questions. Those are not valid questions for the particle world. I mean, how come these people ask only about the rope and only in the context of the rope model? They never ask those same questions to the quantum or the relativist mathematicians. Okay? So that's where you got to start. You got to ask them the question first before you come here. When you can tell me that you saw the particles and that you saw many particles at the same location at the same time, or you saw particles going through each other, or that one particle can be at two places at once, when you can show me, that you got proof for that, evidence other than testimony from an idiot mathematics, if you can show me proof, an experiment where we can all take a look and see how all these particles occupy the same location? You know, unless you can come with all that evidence here, you got nothing. You got absolutely nothing. You can't even ask the question. Okay? First, ask the question to quantum. How do particles occupy a single space? How does one particle occupy many spaces? Okay? And that's when you take William of Ockham. You go with the least number of assumptions. So, you know, we never say that a rope can be at two places at once, for example. So that's what quantum says, that their particles can be at two places at once. Ask that question first. Get that problem resolved before you come here, okay? That's the way it works. And again, he talks about seeing, and then he goes into simply, gravity is a force. Well, no, force. A force is a force. We covered that the other day, you know. What is a force? Force is a concept. But he says, more than a concept. More than a concept. I don't know, concept plus one. He thinks it's an object. He's treating force as an object. He says, that's a real object, whereas the rope is a, you know, just like we saw the other day. A rope is an assumption. And because it's an assumption, it's not a real object. On the other hand, this concept called force, we know it's real. We know it exists. Why? Because there was this force that blew my house down. Well, yeah, but maybe it was the air. You know, I mean, where was the force? What force are you talking about? See, what these people say, or what they're thinking is, you know, you have a horse pull on the cart, or you have an elephant push on the cart. So they say, okay, here we needed an elephant, here we needed a horse, we can see those. And so they generalize, you know, and they say, well, you know, what moved the cart really is a force, okay? So they don't worry about the object that did it, because it could be something pulling from the front that they can see, like a horse, could be an elephant, could be a tractor pushing, could be a group of dogs, you know, huskies pulling on the sled. So they have all these objects. They say, okay, we're going to generalize. We're going to say a force moved the cart forward. And they forget about the object. But see, that's because you can see all these objects. Now, when you come to gravity, now you got a little bit of a problem because you can't see the mediator. And they continue to introduce the word force. They say, well, here's the force that moved the ball down to the center of the earth or to the ground. You say, okay, but what pushed the ball or what pulled on the ball? In either case, it doesn't matter. And at that point, they say a force. Yeah, you can't use the word force. Now we need to identify the physical object. We need to identify the elephant that's pushing the ball or the donkey that's pulling on the ball. Now we need to identify that physical object that's mediating that transaction. And if you say there is no object because I can't see or touch it, then you're in effect introducing spirits in that same space. You're doing it with black magic. You're saying there's nothing there and the ball is being pushed or pulled by what? Spirits? I mean, you know, what are you going to put in that area? And that's what these people have in their mind. Gravity is a force, more than a concept, as we can observe its effects on objects of mass. Yeah, they're just worried about the cart, the fact that the cart moved and not what moved the cart. That's the problem. Okay, so yeah, we have a problem with all these people because they are irrational individuals. Okay, here's another comment. Okay, I think from the same fella. We cannot find when we cannot find an object in nature that can be likened unto an invisible construct, we need to avoid introducing observable constructs to describe a construct that it is itself not observable. Okay, so he's saying if we can't see it, we can't touch it, then we should not introduce objects in that area. In other words, he's going to do spirit. He's going to do black magic. He's going to say that the cart we can see, and we can see the elephant pushing or the horse pulling. We can see those. So he says we can make sense of that because we can see every object. But we can't see certain objects. Then they don't exist, and you should not mediate that with objects. Oh, how about the air? I mean, you know, the air blows on your face, right? Blows your hair up and down maybe, right? So what moved your hair? You can't see it, so because you can't see it, it's not an object. And forget about detecting, because now we're talking about only seeing. So seeing cannot be a criterion here. You can see that we cannot use the word see as a criterion for that invisible stuff, because you can't see it. period. You're not observing. You're not using your eyes. You can't see air, fortunately, right? Except in New York City sometimes, But he says definitions are not the solution. We're not going to use definitions. He says, don't use definitions because they destroy my religion. And he talks about truth. And of course, he says that they use this logic system to talk about things like infinity. What logic? Infinity is irrational. Only mental patients use the word infinity and say it's logical. Logical to what? Not in the physical world. In mathematics, you can say whatever you want. You can say that, time is infinite and motion is infinite, and you can say whatever. The number line is infinite. In math, you can get away with whatever you want because they're all abstractions. But when you come into physics, now we're talking about something else. Now you can't use the word infinite or infinity, as we've discussed in the past 3 or 4 sessions, because infinity is an irrational term. Infinite is an adjective. Infinity is that adjective turned into a noun. That's what they've done. They turned an adjective into a noun. And now they talk about infinity, some location, some land of Oz where you go, or I don't know, the end of the rainbow. I don't know what infinity is. What is infinity? Infinity is a place, a location where you go there and say, oh, this is infinity. So we don't have any use for the word infinity. And we don't have, in fact, any use for the word infinite either, adjective, right? Because in physics, we define object as that which has shape. And there is no object that is infinite, like infinite triangle. How do you know it's a triangle if it's infinite? I was going to discuss that later on, but just real quick, Euclid and all the Greeks, essentially, they talked about the plane being infinite. And if the plane is infinite, what kind of plane is it? Is it a circle? Is it a square? Is it a triangle? What's the shape of that plane if it's infinite in every direction? Okay, so this is the problem. The problem is that this word infinite has no place in science. It only has place with abstractions in mathematics. It's like just used to say, yeah, I can count forever. And the correct word is incessant. You can count incessantly. That's what it is. That's what a number is. The word number means to count. It's a verb. It's not a noun, but they treat it. The mathematicians have turned it into a noun. They say number. No. There's no such noun as number. Not in science. In ordinary speech, you can say whatever you want. In science, the word number means to count. It's a verb. So, and they turned it into the noun number, and they turned the word infinite into the verb infinity, the adjective infinite into the noun infinity to talk about what? Incessant counting. That's what it is. That's how all this developed. Anyways, he talks about truth, logic, and infinity. Obviously, has very little understanding of physics. But it's interesting that this fellow also talks about observations. Okay. Now he just mentioned that you cannot observe gravity. Okay. And he said you refuse to make observations, which are called experiments. Okay, yeah, we have no use in science for observations or experiments, because science is about explaining and not about observing and gawking, or about doing experiments. Here, I do a gazillion experiments. I let go of the pen, okay, always falls to the floor. Okay, so I did 1,000,000 experiments. And what did I learn? Because you do repeatable experiments, you understand how gravity works, what the mechanism is, just by doing experiments. I mean, we've been doing experiments with gravity now at least 400, 500 years, if not much longer. People knew that the apples fall to the floor from the tree since the days at least of the Greeks. And they probably pondered, they said, how does this work? Well, what is pulling it down? And they never addressed that because they didn't have enough understanding of gravity or anything like that. But that's what they did. They saw it. They understood gravity in that sense, that everything falls downwards for some reason. They could not explain it. And they probably had a word for gravity, I guess. They probably say, oh, yeah, that fell to the ground. Why? Gravity. And that's all they could say because they didn't understand. So the fact that you do a repeatable experiment, you stand, looking at the tree and you see all these rotten apples just slowly fall. One falls, the other one falls, the other one. So you did observation, you did experiment, and what's causing the mechanism? What brings the apple down? Do we still know? So no, experiments and observations have nothing to do with science. We do not gawk in science. We have to explain. That's why observation, experiment, and math have nothing to do with physics or with science. Okay, we don't do experiments. You want to do experiments, that's technology. That has nothing to do with science. Science, we have to explain what a magnetic field is and how a magnet attracts another. That's the type of thing we have to answer in science. Okay. And so again, repeatable observations, and he says that's the first step in the scientific method. Well, I don't know, scientific process. I guess he meant the method as well, right? And no, there's no provision for that in the scientific method. Here's the scientific method, okay? Here it is, you see it. Okay, and step one says assumptions. You need to have the objects, the definitions, and the initial scene. Where in there do you see a provision for observations, for gawking, and for repeatability and all this nonsense that he put in there? No, there is no, the first step is there. That's step one. It's assumptions. Okay? You need to present the objects that you're going to be using to explain your theory. That's what science is about. Scientific method is explanation. You have to have a way of explaining something in a rational manner to another human being. What is rational? That you do not move concepts around. Primary part of that definition, primary criterion. Okay, there are others as well. You got to use your definitions consistently, etc., etc. But the point here is that the first step of the scientific method is the assumptions. Detective goes to a crime scene. The first thing he has to do is describe the scene. Okay. And those are his assumptions because he can describe the scene, but when the prosecutor comes to court to present his case, the people there, no one has been at the crime scene. So he's got to paint a picture of what the police men saw when they came there, or the detectives saw when they came there. And maybe the defense attorney paints a different picture. He says, no, I saw something different when I went there. So they have different assumptions. Okay, there are different assumptions of what the foundations of each of those theories will be based on. And so, yeah, the first step is assumptions. You have to tell the jury what objects were involved. There was a murder. Was it a knife? Was it a gun? Was it poison? You got to present the objects. Those are the objects. Without that, you just can't go into your theory and start explaining, this is what we think happened. No, we still don't know what happened. What happened first? Then you can tell how it happened. That's the theory, okay? So no, these people want to skip over these steps and they say, we don't need the objects. We don't need the definitions. I want to go directly to the theory. This is the issue. Okay, and this fellow continues. He talks about first cause. It's interesting that he says that you need observation, but then he says we have never observed an existence spawn to being spontaneously. In other words, nothing ever turned from space into an object spontaneously all on its own. So he's saying we need a creator. Well, I'll even grant the creator. Let's grant the creator, okay? We have this all-powerful magician, okay? I want to know the mechanism, okay? So if the creator, or maybe an alien from another planet who's super intelligent, whatever, I don't care, and has super technology, right? We bring him over, and he's going to go in there and he's going to say, let me show you how I create something from nothing. He goes, waves his magic wand, goes poof, and a rabbit appears in front of you. Okay, there was nothing, assuming we do this in space where there's, vacuum, total vacuum, okay? Suddenly a rabbit appears in front of you. Fine, okay, so he made the trick. He promised he was going to make that trick. He did it. Now I want to know the mechanism. Please explain the mechanism, dear God, dear Klingon. Tell me how you did it. How did you convert something into nothing? That's what I need to know. If you cannot tell me that, then you're imagining nonsense. You've seen too many Hollywood movies. That's your problem. Something cannot come from nothing, and something cannot turn into nothing. Okay? Something is that which has shape. That which has shape cannot lose length, width, and height, or at least two of those dimensions, and turn into nothing. By what process? Explain the process. Don't tell me it can, just tell me the process. I need to know the mechanism. And if you can't tell me the mechanism, then this nonsense about creating, even with your magician, does not work. You got to tell me the process. And of course, he's assuming there's a creator, but then, as always, these atheists have many years argued, who created the creator? We got the same problem. And if you're going to say, well, the creator's infinite, the creator's eternal, he's always been around. Well, we don't need the creator for that matter. We can say matter has been around because matter cannot turn into space. Space cannot turn into matter. Something cannot turn into nothing. Nothing cannot turn into something. Therefore, matter has always been there. There is no moment of creation of matter except in the religion of mathematical physics, where they talk about Big Bang and energy hitting energy and separating and all this nonsense, okay? Other than that, irrational folk, they don't believe in, and they don't accept the theory, the explanation that matter popped in from a concept such as energy or whatever these people come up with. No, matter has always been there, and matter will always be there. Because we have no way of converting matter into space. We have no way of converting something into nothing, that which has shape into that which doesn't have shape. That which has shape has length, width, and height, at least in the real world. We cannot have it lose length, width, and height and turn into nothing. How do you do it? What's the process? Just explain the mechanism and I'll eat my words. All you got to do is explain the mechanism. And if you cannot explain the mechanism, you're dreaming. You're talking about religion. You're an irrational individual. Okay? What does he say? He talks about faith, creation, and yeah, you got religious people who just pounce on this side and they start talking nonsense. And that's what it is. It's irrational people. And they believe in creation. They believe that you can create something from nothing because everything that exists had to have a cause. Well, the causer, the first cause, what caused him, or it, or whatever, right? Or her. But let me give you a little something under the rope model, okay? For those of you who are more or less familiar with the rope model, here's the underlying hypothesis. We have a single closed loop thread in the universe. That's all there is. If we were to unwind or disentangle or disassemble every atom in the universe, okay, we would end up with a single closed loop thread, okay? And that's the starting point. Now, I'm not saying we can reach that. I'm just saying, just imagine. Let's make believe for a second, okay? So there's only a single thread. This thread twines around itself and eventually creates atoms, okay? And these atoms are connected also by these twined threads. So we have the atoms made of threads, and they continue to another atom through what we call the electromagnetic rope, which is a twined thread, which then immediately forks out into another atom and so on down the line. And all we have in the universe is just threads forking into atoms and then unforking back into ropes. That's all we have. Now, let's just look at a possibility here. All those on the bottom, you can think of those as galaxies, you can think of them as atoms, it doesn't matter, they're all interconnected, they're physically interconnected, that's our universe there, and if that's true, then the question is, can all that mesh disentangle itself, okay? Now, personally, I don't think it can. I cannot imagine how it can disentangle. I think it's there forever. Okay, it's always been there forever, and it always will be there forever. There was no moment of creation. People have no way of conceptualizing something that doesn't have a starting line. And this is the big problem that they have. They have a serious problem. Just like they have a big problem with touch and see. They say, but I can't see gravity. I can't touch gravity, so there's nothing there. And that's an issue of definitions. It's shape and not see or touch. Likewise, all these people have a problem, a serious problem, and I think most people will have, that matter has always been there. And let me tell you one serious problem with that, okay? And now you got to really get a beer and really, because it's going to shock you. There's never been a first human, a first living entity. Human, living entity, doesn't matter, really. Before us, trillions, I'm using the word trillion, trillions of years ago, before the Big Bang, all that nonsense of mathematical physics, there were other atoms forming other planets or other stars, etc., etc. And in that trillions of years ago, there were probably humans, very, very likely were humans. And trillions of years before that, there were other humans. And trillions of years before that, there were other humans. I hope you understand what I'm saying. There was no first human in the universe. Now, I hope that blew your mind a little bit if you understood what I'm saying. There was no first human. Before the last human that was born before us, there were others before that, and before that were others, and before that were others. And there were other planets, there were other living things in different planets around the universe, and you just keep going back. You say, well, what was the starting point? I want to know what the starting point is. You have two possibilities. There was a starting point or there wasn't. And I'll just give you a scenario for the starting point, okay? Not that I agree with that, I doubt it, but I'm going to give it to you anyways, okay? Let's assume we disentangle all the matter, we end up with that closed loop thread. So let's assume that over the centuries, we're talking about trillions of years at least, so gazillions of years, all the matter in the universe disentangles and turns into this thread. It doesn't have to be a perfect thread, it could be just wiggling there, but it's a closed loop lasso, whatever you want to call it, okay? And now it begins to tangle again, turn into atoms, ropes, and we end up with a universe in which we have, again, stars, planets, atoms. It starts with atoms, then works its way up. And we have another universe. Essentially, we've recreated the universe. Now, after trillions and trillions and gazillions of years, it disentangles again. We end up with this loose, closed loop thread, okay? And now a new universe begins. Only in that sense can you understand a beginning of the first human or the first living entities somewhere when that thread comes in, forms atoms, and then again from those atoms you can say a new universe. Otherwise, the thread itself is always there, okay? And more than likely, the universe never disentangles. I cannot imagine, I'll give you gazillions of years, as much as your computer will, as many zeros as your computer can handle. And I don't think you can disentangle all the matter in the universe. I just have a problem with that, but that's just my version of it. But if you're going to ponder a first human, or a first living entity, or a first sun, a first atom, you can talk about anything here. If you're going to talk about the first atom created, well, you can think of that as the thread that has untangled, and now when it's tangling, it forms atoms, ropes, and from there on forms all the matter in the universe. And so this answers a question that another fellow asked here, another comment. And it goes something like this. The fellow says he didn't have good English, but we can still try to make sense of what he's trying to say here. He says, if all universe formed by a single electromagnetic thread, then why so many different things? We can't visualize further. We can't visualize further how different things are formed from single electromagnetic thread. How the single electromagnetic thread formed different things. And yeah, the thread just forms atoms. And it's from atoms that we're going to form things. A table is made out of atoms. The wall is made out of atoms. A tree is made out of atoms. The rock, the dog, everything is made out of atoms. Okay? And so there are different types of atoms. The atoms that make up a living entity, such as a dog, right, are not the same atoms that make up the silicon in your wall. So there are different kinds of atoms. They're all made out of electromagnetic threads, according to our theory, but the issue is that they're not the same types of atoms. So you can build different kinds of entities, living entities here and inert entities there, because they're using different kinds of atoms. You won't see life forms made out of silicon, and a lot of people speculate on that and say, oh yeah, there could be in other planets or in another part of the universe, silicon-based intelligent creatures. And I say, no, no way, absolutely no way. And, it's a lot of Hollywood dreaming, but the issue here is that you cannot produce silicon life forms, and one way that you can prove that to yourself with a little bit of evidence, just go through the solar system. You got a lot of silicon there. No living entity, especially made out of silicon, will be found there. The only thing we can find made out of that's living is made out of carbon. Okay, so there are no living entities made out of silicon. Silicon as the primary chemical element, and we get a lot of silicon in the solar system. It's strange that nothing developed there. And I'm sure if we go to another planet, we would find the same thing. If we go to another planet, we'll find carbon-based life, because I think life is strictly carbon-based. You won't find silicon-based life. Just to mention one chemical element, you can mention any others. As far as I'm concerned, it's the same. There are no life forms that are non-carbon-based. Okay? At least I cannot imagine, but if you can build one in the lab and show us how it crawls out of the flask, like we had a couple of scientists in the 50s, okay, Urey and Miller, and they ran an experiment where they put carbon in this flask, zapped it with electricity, and, well, they didn't have a bug crawl out of there, but they did create amino acids, which is a good way of showing that there was a possibility that there were a chemical reaction that started the life process on Earth. And if you can do something similar with silicon, it'd be great. But I cannot imagine silicon-based life form. But if you want to imagine, well, yeah, but it's no good, because there's no way first that you can prove it. You can only fantasize about it. That's all you can do, and that's great. I don't know what use that is. It's just speculation. Okay. Okay, so what's the issue? The bottom line here is that anyone who wants to come to this channel and put a comment and wants it answered, he's got to define the word object. We do need objects to do physics, and the first thing is, tell me what an object is. Define the word object. If you cannot define the word object, then we have to, or defend it. You can have your definition, say, oh, object is that which moves, or that which has mass, or that which has color. You can say whatever you want. And I show that you can't use any of those, but we'll be glad to tear your definition apart. So let's start there. Let's have you defend your definition of object before you make a comment. But if you're just going to make a comment about your beliefs, your religion, yeah, sure, go ahead. But I'm only going to address people who can justify their definition of object, show why the definition of shape is wrong, and why they need to introduce see and touch, especially those two, because those are the ones that they use informally when they attack the rope model. They say, oh, but I can't see the rope and I can't touch the rope. Yeah, because that's not what an object is for the purposes of physics. Object is not that which you can touch or see. That's why you're attacking a straw man. You're saying, I can't touch and see the rope. Yeah, because that's not what an object is. An object is that which has shape, and not that which you can touch or see. So you're using the wrong criteria, you're using the wrong properties, you're extrapolating properties of ordinary speech, of your ordinary experience with the things that you see and touch, and you say, well, I can't see what mediates gravity. Yeah, because that's the way Mother Nature made our universe. Fortunately, can you imagine if she would have made even particles? Let's do it with particles. I mean, you don't like the ropes? Let's do it with particles. Imagine she made the particles of gravity visible and touchable. We'd be bombarded with bullets every 2 seconds. We'd be all those gravity particle, all those gravitons that are hitting me. No, she was smart. She said, look, we got to make the gravitons invisible and intangible. Okay, and likewise, we have to make the ropes invisible and intangible. And so anyone who talks about tangibility and about invisibility, he's got to start with the word object. He's got to know what an object is. And let me show you some of the problems that these people have, because see, it turns out that when people ask questions, they go like to Quora. I write in Quora quite a few articles. Try to write one every so often when I get the time. And people go there and ask questions. Laymen, they want to know certain things, and they ask qualitative type questions. They don't want you to give them an equation. I mean, some people do, but most people say, hey, just tell me how this works. Tell me the mechanism. How does light work? And here's a set of questions that I pulled out just at random today because it more or less had to do with a subject matter. Okay. And first question there, it gives it to you in a nutshell. So, why can photons pass through each other? Good question. Without addressing the others yet, so photons go through each other, and these people, and it's like nobody asks questions about like, so photons go through each other. They can also be at two places at once. They tell you that nobody questions that, but as soon as I say the roads can cross through each other, what do you mean they don't get tangled? Well, why don't you ask the questions here? Here's where you ask the questions. And what's interesting about all these questions here, you see a list here. Why does light pass through glass? Why does infrared radiation not travel through glass? Why are we able to see through materials like glass? Why can we see through glass but can't see through wood or steel? These are very important questions. These are very basic questions. The problem with them, the first big problem, all the big names in Quora, I'm not going to mention any of them. You can look them up. Just look up the word physics for Quora, find out who the physicists are, who have millions of hits, right? And see if any of them answered any of these questions. And none of them do. They all avoid. They talk about idiocy such as quantum particles when they give you equations. But here, this is something simple. Why don't they answer these questions? Why do they avoid them? All these simple questions, how a magnet attracts another, how light avoids, how photons go through each other, you'll never see their names there. Ask them. Find one of these physicists, so-called physicists, big name for them, people who answer physics question, and ask them to answer that question. See if they'll tackle it. Okay? So what happened today with my son? We did a little experiment, okay? And why did we did the experiment? We did it because of this. In the book, okay? In the book that the rope hypothesis, I put this picture in there. If you look down 3 meters of water in a pool, right, you can see your reflection down at the bottom, okay? Now people say, well, no, you're not really looking at the bottom. Well, what's reflecting is the top of the water. What's reflecting your face is the surface of the water, okay? A lot of people have this idea. Well, first you'd be wrong because you can see with your own eyes the drain, the dark drain in one of the corners of the pool. You'll see it right through the water. And hopefully that's not on the surface. Okay, so that's the first problem. But then I had to show that this is also true, that you can see your reflection at the bottom of a pool, whereas you cannot see your face through a sheet of paper, through a thin sheet of paper. Okay? And so this is what the experiment was about. It's a very expensive experiment. Don't try it at home unless you're in the company of a trained relativist. Okay? It's a very dangerous experiment, very expensive, okay? So viewer discretion is advised, okay? So here it goes. First, we went in there and we put a mirror, okay? We put a mirror and we filmed it, okay? We filmed it with the camera, and you can see the camera, okay, films itself, okay, in the mirror, okay? And then we put a sheet of paper, and you can see that it blocks the camera. There's no reflection now, okay? So the light does not go through the piece of paper. and the mirror does not reflect through the piece of paper to our camera. Okay, so we can film this back and forth, okay, and you can see that the paper blocks any reflection. You do not, in other words, light does not go through the paper. And that's a very thin sheet of paper. Here it is. That's the one we used, okay. I mean, I hope you can see how thin that thing is. It's very thin. Not even a millimeter. Maybe a micrometer, I don't know. I haven't measured it, but it's thin. You can't see through a sheet of paper. In fact, here it is. Can you see me? Hopefully that blocked the light. Light does not, my image does not go through the paper, okay? So hopefully I've established that. You can do this very expensive, very dangerous experiment in your own dark basement. And here, okay, here we did the experiment now with water, okay? So check closely. I cleaned my trash can, my kitchen trash can. What we did was film, and we can see right through about a cubic feet of length of water, which is from your elbow to the tip of your fingers. That's how deep that trash can was. Okay, so the trash can is a little less than maybe 2 feet, something like that, deep. We filled it with water right on top of the mirror, okay, and right through the water. Once we stabilize the water, you can see yourself at the bottom of that pool. Okay, you can see your image there. So the mirror reflects right through the water. So it's not that you're seeing your reflection at the surface of the water. You're seeing yourself at the bottom of the pool. Okay, that's the point of this experiment. That means that water, which is, you can see, much thicker in this case than the little sheet of paper. I mean, how much water do we have there? You know, again, about 2 feet of water. That's how deep that was, okay? So you have 2 feet of water, all these atoms, all these molecules in your way. And light goes both ways. It goes from your image to the mirror and back to your face, because you can see yourself in the mirror down below. And that same thing cannot go through a thin sheet of paper. That image, you know, you can't see me through there. And I can't see you either. So is it the quantity of atoms that blocks light? Is that what it is? Well, obviously not. See, when these people ask these questions, why can light go through glass? What are you going to answer? What are you going to tell your 10-year-old kid? You know, why? What's the cause? What's the mechanism? Does light go through the window or not? And you say, well, yeah, sure it does. Well, that's only if you use particles. Then you talk about going through. And of course, you run into millions of problems, anyone using particles, because now you got to talk about hit and miss. How do they explain these things? Well, the way they explain them today, they don't explain them. Again, none of the big name so-called physicists, mathematical physicists, whatever they are, gets into core and answer these questions. You'll never find an answer from a big name guy, you know, a guy that's got some authority, because they can't answer the question. They can't rationalize it with particles. What are the notions that they have that they suggest, the theory, the explanation, physical interpretation? Well, one of them is that the photon ball, right, because it turns into a ball, right, is absorbed by the atom, and then the atom releases the photon in a different direction. So, you know, light goes through the window, and it hits an atom. The atom absorbs the photon, the energy, whatever nonsense word they put in there, and then it releases it back again. That's how you can explain reflection, or you can explain refraction, okay? And another one is that it functions like a pinball machine. You have the photon and goes bouncing between atoms, okay? So it bounces between them and then comes out. And why is that important? Well, because they're trying to explain the speed. they're saying, well, why does light go slower through denser material? Like in the case of glass, and I'm telling you because I worked many years with glass, SiO2, okay, we had to build layers of oxide over silicon dioxide, that's the name of it, okay, for glass. And we had to measure these thin films, and we measured them with an ellipsometer. Light went in there, came out, and the machine to tell you the thickness of that layer of oxide. Why? Because according to official religion, because it's not even an explanation, they use something called the refractive index. That means that light goes slower. Okay? Light goes slower. Light moves slower through the film and then comes back out into air and now goes faster again. And what they cannot explain is that acceleration. We can all understand, you know, you crash your car against a tree, you go a little slower. We can all understand that. So here you have light going through air, which does not provide too much resistance, too much friction to the photons, right, to the stream of photons. It hits glass, and now there's more solid stuff there, so now light crashed against the tree, right, goes slower, reflects on the bottom layer, and we use silicon underneath, the silicon dioxide, hits the silicon, bounces back up through the layer, always slow through the layer, and then moves fast again. Well, why did it move fast again? What speeded it up? Where did it get its energy to go faster? And they cannot explain that. They cannot explain it with particles. And here's an image of that so that you can see visually what I'm talking about. See if I can get it here. Okay. This is what they have in mind. You have a layer of silicon, which is the gray part at the bottom. You have silicon dioxide, which has been grown on that film. Okay, it's a very thin film. And you're going to try to measure the thickness of that film. We use an ellipsometer, but you don't need to know any of that. All you need to know is that if we shine light on the surface of that glass, that upper part is glass, right? They say that the angle changes. The angle of the particles or waves going in there changes. And then when it comes out, as you can see, it goes slowly through the glass, and then when it comes out, it goes faster again. It goes at the same speed it had come in. And the question is, what speeds it back up? And here I've labeled these so that you can see a little more detail what I'm talking about. Okay, you can see velocity 1 coming in, and then it turns to velocity 2, which is slower, and then goes back to velocity 1, which is faster. And they just used Snell's law, okay? And so what they do is they just say, look, we can calculate it. We can tell you how slow light went through the film, okay? Yeah, but you're not telling me the mechanism. Is it little balls? Is that what it is? Is that what light is? Is light just a bunch of tiny balls? We have to identify this. I mean, you have to identify the invisible mediator, the actor. You have to identify the actor. And they don't want to identify the actor because if they identify the actor as a particle, then they cannot explain this. And there's no way they're going to explain it with particles. Okay, so how do we do it in rational science? Okay, here you see the mechanism in rational science. For comparison, you reach your own conclusions. I mean, you know, all we can tell you is what our mechanism is. Okay? Oh, sorry. This I wanted to show that a reflection in the lake or in the ocean or whatever is not just a surface problem. That by putting a mirror at the bottom of the lake, you can, if it's clear enough, you'll see your face. Okay, but here it is. Here's my mechanism for this. Okay, here you see it. Okay, there's no particles moving in or moving out. All you have is torsion from atoms to atoms. And light travels always at the same speed because what changes in this case is the frequency in exchange for wavelength. But little c, 300,000 kilometers per second, is always the same. And here I have labeled this as well so that you are well aware of what I'm referring to here. Here it's labeled, okay? You have the short links, okay? and the long lengths. The long lengths are the ones that go through the whatever medium, a denser medium you have. C, little c, is always equal to frequency times wavelength. That's the equation down there. If you increase the frequency, the wavelength goes down, and if you increase the wavelength, the frequency goes down. And what we called it is we called it link length. Okay, and yeah, you have SiO2. You have all you have is torsions, and so there is no motion in the sense of moving from A to B. Light does not. The rope does not travel. The rope stays in place and just torques from atom to atom. And all you're doing is changing the frequency for the wavelength, and that's why the light, when it comes back out, to use that terminology, is at the same speed as when it came in. And it's also at the same speed within the denser medium. Why? Because there is no such thing as speed. Torsion is always going to be the same speed, always. The only thing that changes is the frequency in exchange for the wavelength. Okay? That's the mechanism. You don't have to believe it. You just have to understand it. You reach your own conclusions in your dark basement. If you think you can figure this out by running experiments, you're wrong. There is no experiment you can run to verify an invisible, intangible, unsmellable, untastable, unhearable entity. You cannot use your five senses. You cannot use experiments to address this issue. You're not going to find out what light, what gravity, what magnetism is through an experiment. We've done all the experiments. I'm sure Mr. Faraday, who worked many years after Davy died, he took over the laboratory over there, and he started doing all kinds of experiments with magnets, just about all the ones that he could think about. We did a few more after that, but he did quite a bit. He tested magnets on electricity until he dropped dead. And he couldn't figure out, through experiments, what electricity is or what magnetism is. And so today we have this irrational interpretation of electricity as the flow of electrons. Why is it irrational? Because they cannot draw the atom before they do their mechanism. I need a picture of the atom. And the picture of the atom has to show why the electron bead is tied to the nucleus. That's what you got to show. If you cannot explain what binds the electron to the nucleus, you cannot tell me what keeps it there. Why doesn't it spontaneously fly away and turn into an ion? If you cannot explain that, you can't even start to tell us anything about electricity. Electricity is not the flow of beads, unless you can justify it. And the question is, no one has been able to justify the atom to begin with, and so you're basing electricity on an atom that you cannot justify. That's the issue. The issue is the electron bead would have to have some way of sticking to the nucleus before you set it in motion through a potential, to use that terminology. So this is the issue. The issue is they don't know what electricity is. They don't know what magnetism is. They don't know what gravity is. They don't know what light is. They don't know any of these things. And the question is, how can they be, because they say they've proven and they know and they, and everybody raised their hands and voted for these theories, right? And if that's the case, hey, it's very simple. Just explain these simple things. Why does light go through glass? That's all you got to explain. I mean, here, tell me why light doesn't go through this piece of paper and why light goes through glass. Why is glass? I like the answer one guy gave. He says, well, the reason light goes through glass is because it's translucent. And those are the kinds of answers these irrational individuals give you. Now, you got to give me a mechanism. How does light do it? And under the rope model, it's very simple. Light does not go through. Light does not go through a window. Light does not go through a window. The rope ends in an atom which retransmits, relays the signal it received to your eyes. So the light of a sun, that reaches your eyes is through a window is reaching your eyes indirectly, because it's the atom in the glass is retransmitting the signal, the torsion signal it received. It's retransmitting it through quantum jumping. It's being stimulated by the frequency that the sun gave that torsion. The atom pumps at a faster rate with the sun than at night, and it's retransmitting that to your eye, that same frequency to your eye, to the atom in your eye. So it's all connected. It's all through a channel known as the channels, gazillions of channels that these ropes are. And you say, I can't touch them, I can't see them. You're an irrational individual. You have to start by knowing what an object is. An object is not that which you can touch or see. An object is that which has shape. Okay? Let's see, do I still have time? No, I don't have time for any more. Again, I'm going to have to postpone Euclid and good old Mr. Aristotle to next time. Okay? We'll see you then, on Sunday. We'll see you then. Bye-bye. And by the way, those people who can translate the book, please contact us at tokakaka@hotmail.com. And we're going to start our Spanish channel now in March. And so we're going to be notifying people in different parts of the world that they may want to tune in and learn something. We'll see you on Sunday. Bye-bye.